Two things about AWS Lambda blow beginners' minds, and one of them can cost you $1,000. First, you can run real code with no server to rent, patch, or babysit. Second, people have built a function that accidentally triggers itself in an infinite loop and runs up a massive bill overnight. By the end of this video, you'll understand exactly what serverless really means, and you'll never build that recursive bomb. Here's the whole idea in one picture. Lambda is an on-demand worker who clocks in only for the exact seconds a task arrives, then clocks out, you pay per task, never for idle time. So let's kill the biggest myth first. Serverless does not mean there's no server. The servers absolutely still exist. Amazon owns them, patches them, scales them, and simply hides them from you. Your code gets dropped onto one of those servers for a few milliseconds, runs, and is lifted right back off. You rent by the millisecond, not by the month, and when no request comes in, nothing runs and you pay nothing. The worker shows up with their own desk and laptop, does the job, and takes the desk away with them. You never bought or maintained it. Before you reach for Lambda, know it's one of three kinds of compute. Lambda is the gig worker, perfect for short, event-driven, bursty tasks under 15 minutes with zero servers to manage and pay per request. EC2 is the full-time employee, always on, full control of the operating system, but you pay 24/7 even when idle and you patch it yourself. Fargate is the temp agency shift worker. You run containers without managing servers, but you pay for the whole running shift. Short and event-driven, pick Lambda. Always on, pick EC2. Containers without servers, pick Fargate. Here's how Lambda actually runs, and it's not like a server sitting there listening. The lifecycle is event-driven. 1. An event arrives from a trigger. 2. Lambda finds a warm environment or creates a fresh one. 3. Your handler function runs and returns a result. 4. Eventually the environment is torn down. The key consequence, no event, means nothing runs, and nothing runs means no cost. The worker is at home doing nothing, completely unpaid, until the doorbell, a trigger, rings. Let's build one in the real console. We go to Lambda, choose Create Function, and author from scratch. We give it a name, VOncloud Demo FN, and pick a runtime, like Node or Python. And notice this, Lambda automatically creates an execution role for the function. Remember that phrase, execution role, because it's the single most important thing in this whole video and we'll come back to it. Click Create, and in seconds you have a live function. You've just handed the worker their very first job sheet. And here's that job sheet, the handler. This is the entire function, a handler that receives an event, does its work, and returns a response. Here, it just returns hello from Lambda. That's the mental model. Your code is one self-contained job. It starts here, finishes here, and hands back the answer. You edit it right in the browser and hit deploy. No server to SSH into, no operating system to manage, just the function. Start here, return the result, done. Every handler is handed two things, and beginners ignore both. The first is the event, and this is the part nobody explains. The event shape is the trigger. An event from S3 carries a bucket and a file key. An event from API Gateway carries HTTP headers and a body. An event from SQS is a batch of messages. They look completely different, so you parse the event based on who sent it. The second is the context, runtime metadata like the request ID for your logs, how many milliseconds you have left before timeout, and the function name. The job sheet's format depends entirely on who handed it to you. Now the big one. The reason for almost every Lambda failure you'll ever hit, the execution role. Look here under permissions, the function has its OWN identity, this execution role, completely separate from you, the user. Right now, it can only write logs to CloudWatch. So the number one Lambda error in the world, my function gets access denied writing to S3 or DynamoDB, is almost never your permissions. It's that this role lacks the permission. The fix is always open CloudWatch logs, read the literal access denied line, then attach the policy to the ROL. The worker has their own keycard. If it won't open the supply room, your boss's access doesn't help, you fix the worker's keycard. So it rings the doorbell. Triggers, and you wire them right here with add trigger. There are 4 you'll use constantly. S3, run when a file lands in a bucket. A PI gateway, run on an HTTP request, which is how you build serverless web APIs. EventBridge, run on a schedule or an event bus, the cron of the serverless world. And SQS, pull and process messages from a queue in batches. Same worker, different doorbells, a delivery buzzer, a phone call, an alarm clock, and an inbox tray. Here's a trap that breaks real apps. Lambda forgets everything between calls. It is stateless. If you increment a counter in a global variable, it will not reliably add up, because the next call may land on a brand new, empty environment. The only writable disk is /tmp, and even that is ephemeral, wiped when the environment is reaped. But there's a useful twist. Code in the global scope runs once per cold container, which is exactly where you open a database connection so it gets reused while the worker stays warm. Think of a fresh temp worker each time who remembers nothing of yesterday. Now one slider that controls both speed and cost, memory. Here in general configuration, you see memory at 128 megabytes and timeout at 3 seconds. The thing nobody tells you, raising memory also raises CPU and network proportionally, so a heavy function with more memory can finish so much faster that it actually costs less. Watch that default 3-second timeout. It silently kills any function calling a slow API, and know the hard maximum is 15 minutes. Longer jobs belong on Fargate or EC2, not Lambda. It's like paying for a bigger desk and a faster laptop. The job finishes so soon, the total bill can drop. Let's talk cold starts, the price you pay for having no idle server. The very first call has to download your code, start an execution environment, run your initialization, then run the handler. That's a cold start. Call it again moments later, and the environment is already warm, almost instant. Compiled languages like Java start slower than Python or Node. You shrink cold starts by trimming dependencies, moving setup into global scope and raising memory, and for a latency-critical API, you use provisioned concurrency to keep a few workers always warm. The first time, the worker commutes in and sets up the desk, call again, and they're already sitting there. What happens when traffic explodes? By default, your account runs about 1,000 concurrent executions at once, and Lambda adds roughly 500 new environments per minute. Push past that ceiling, and new requests get throttled. They receive a 429 and have to retry. Two controls help. Reserved concurrency guarantees or caps a specific function's share, and provision concurrency keeps a set number pre-warmed for low latency. If 5,000 doorbells ring in a single second, you only have so many workers on the roster. Some callers are politely told to please hold until more count runs. Now pricing, and the trap that ends this video where it began. Your bill is just two parts, the number of requests plus GB seconds, your memory multiplied by how long it runs. The free tier is genuinely generous, 1 million requests and 400,000 GB seconds every month. And unlike most AWS free tiers, it never expires. Now the bomb, a Lambda triggered by an S3 bucket that writes a file back into that same bucket retriggers itself forever, running up a huge bill. The fix is simple, write to a different bucket or prefix, or add a suffix filter. If finishing a task creates a brand new task for the same worker, the meter never stops. Finally, 3 things to finish like a pro, and they're right here in configuration. Set environment variables to configure your function without touching code, but never paste secrets in plain text here. Keep passwords and keys in Secrets Manager or SSM parameter store. Use a layer to share heavy or common libraries across many functions and shrink your deployment package. And the canonical serverless web pattern is API gateway in front of Lambda, the front desk that takes each customer request and hands it to whichever worker is free. That's Lambda the way professionals actually use it. Serverless really means servers you never see. The execution role is behind every access denied, the event shape is the trigger, and pay per millisecond is a gift, as long as you never let a function trigger itself. Each server